Hey, welcome to Zona Mechanica. There is a linked data type of question on bending moment and bending stress. Figure at the margin indicates the weightage of the question, that is 2 marks. Actually, this is a linked data type of question. There are two questions. This is the first one and it will be a bit longer. And the next one is regarding the bending stress. It will take a minute only. A simply supported beam of span 6 meter and 75 diameter carries a uniformly distributed load of 1.5 kilonewton per meter. What is the maximum value of bending moment? Okay, so what is the maximum value of bending moment? Well, as you can see, this is the beam, simply supported beam of span L, and this is the UDL. Let W be the UDL, intensity of loading, which is equal to 1.5 kilonewton per meter, and L is in meter, which is equal to 6. It is told 6 meter. So there will be two reactions. Let this is R1 and this is R2. So clearly the load will be equally shared by the two reactions. So R1 is equal to W into L by 2 and R2 will be equal to same W into L by 2. Now the bending moment. Let us consider a section at X from R1. Okay, so there will be two forces causing the bending moment at section A. One is R1 and another one is this load. Okay, so up to this length, so W into X is the total load in this short span. So clearly the bending moment will be R1 into this distance X minus W into X into X by 2. Since it is a UDL, so we can assume that the total load is acting at X by 2. So W into X, this is the load into the distance X by 2. So we can assume that this load is acting at X by 2. So this is the expression for the bending moment. So R1 is equal to W into L into X by 2 minus W into X square by 2. Clearly at X is equal to 0, it is 0, and at X is equal to L also it is 0. So at X is equal to L by 2, that is at the middle of the beam. So M is equal to W into L into L by 2 minus W into L square by 2, sorry, L by 2 whole square, that is into 2 square. This is L by 2. Okay, so that is W into L square by 4 minus W into L square by 8. So that is equal to W into L square by 8. So this is the maximum bending moment in the beam. So if we put the values 1.5 kilonewton in kilonewton and L is the 6 in meter by 8, then it will give some 6.75 in kilonewton meter. Okay, so this is correct answer, but it's not matching with any of the options given. That is, all the options given are wrong. So in this case everybody will get full marks. Okay.